All right, hello again, everybody. This is part 2 on 2.4. This time, instead of just finding the linear factors and finding all the zeros, whether they're real or not, we're going to actually have to write a polynomial, okay? And you remember that the complex, what was it called? Let me back up here. Here, the conjugate root theorem, okay? The conjugate root theorem says that if a plus bi is a 0, you also have to have a minus bi, or if a plus, b square roots of c, then a minus b square roots of c has to be 1. I'm just making stuff up here for letters, but they come in conjugate pairs, okay? So it says write a polynomial function of least degree with real coefficients in standard form that has a 0 at 0 and a 0 at square root of 2 times I. What we need to realize is that if square root of 2i is a 0, negative square root of 2i is also a 0. So there's our 3 zeros. Then if we write them all as factors, linear factors, and the I is not under the radical, by the way. Okay, minus negative square root of 2i would be plus. All right, then what it says is they have to have real coefficients. So we need to multiply this together. So very carefully, x times x is x squared. X times square root of 2i would be square root of 2i times x. Then when I distribute this negative, it's going to be the same thing, negative square root of 2i times x. And then negative times a positive back here would be negative square root of 2 times square root of 2, I'm doing this one now, would be 2. And I times I would be I squared. So these two cancel each other out, and I ended up with an x squared. But minus 2i squared, remember, is really negative 2 times negative 1, which is plus 2. So there's these two factors foiled together. And then we had x minus 0, which is just an x. So this is where I would tell you you can actually stop. It says standard form, and this is not standard form. And this one's easy to put into standard form. If you just distribute that, you get an x cubed plus 2x. But sometimes at the end, you're going to get real messy answers, and we don't want to FOIL forever. So as long as you don't have any radicals or imaginary numbers left, I'm going to tell you can leave it in factored form. All right. So we're going to start this time with one that says, let's find all the complex zeros of x to the fourth minus 5x cubed plus 3x squared plus 19x minus 30, given that x plus 2i is one of the zeros. Whew. All right, if x plus 2i is a 0, I'm sorry, I can read. Wow. X equals 2 plus I is a 0, then x equals 2 minus I is a 0. Okay, a plus 1i, a minus 1i. So 2 plus 1i, 2 minus 1i are the two conjugates. All right, so what we have to do is write these as linear factors. So x minus 2 plus I, okay, times x minus 2 minus I. Now, we left those in parentheses. I'm going to go over here and work with them a little bit. So I'm going to distribute this negative, and that one's going to become x minus 2 minus I. Whoa. Sorry. And this one, when I distribute this negative, is going to become x minus 2 plus I. Now we're going to FOIL these together. This is a little bit of a painful process, guys. I'm going to distribute this x in red to all three things back there. So I'm going to have x squared minus 2x plus ix. And then I'm going to distribute in blue the negative 2 to all three things back there. So negative 2x, negative 2 times negative 2 would be 4, and negative 2 times I would be negative 2i. Then I'm going to distribute this negative I that was at the back to all three things back there. So I get a negative ix, which I'm out of room, so I'm going to write it under the like term here. And negative I times negative 2 would be plus 2i. You can write it anywhere. I just wrote it so it matched up here. And then I have negative I times I would be a negative I squared, which you can put anywhere, but I'm going to kind of put it by the 4 here because it's going to turn into a real number. All right, so whatever order you wrote all those in, go through and figure out what cancels each other out. Now, negative 2x and negative 2x is negative 4x. So I have x squared minus 4x. And then I have 4 minus I squared.